Visual and technical reading has before, during, and after reading components, but it is considered a during strategy because that is where the tough work occurs. This strategy helps you interpret the graphics. This kind of reading can be challenging. Think of equations in chemistry, figures in engineering, scores in music history, graphs of polling data in political science, and flowcharts in business. Graphics in academic texts make understanding easier. They often consolidate and simplify key information and illustrate important ideas and concepts. Learning from a visual is, at its core, a process of analysis. Basically, whole to parts and back to whole with new awareness. Start with the before layer of academic reading. Prepare to learn from the visuals in the chapter. Preview the entire chapter by asking, what can I learn from this text? During the preview, look at the graphics along the way and glance at the captions. For some visuals, the meaning becomes immediately clear and builds your anticipation. These two visuals seem to give historical perspective. This caption says, "Why is the package thrown to the outside of a turn?" Notice that the package is not thrown at all, but stays in a straight line even when the car turns. This is interesting and makes you wonder how this phenomenon works. Some visuals seem much harder at first glance. Do not spend time on them now. Instead, mark them with a code that means come back to this later, and continue previewing the chapter. Now that you have finished your preview, set purposes to guide your reading. Decide what you want to know and be able to do by the time you finish. For example, be able to state Newton's 3 laws of motion, discuss each one, and explain how they are intertwined. Give several examples for each law and their interactions. Give examples from the text, and give examples from your own life experience and prior knowledge. In summary, before reading, preview the text, interpret easy graphics along the way, mark the hard parts for later, including the hard graphics. Set purposes. What do you want and need to learn from this text? You are now ready to do the during part of the strategy. This is where deeper learning takes place. When you come to a hard visual you marked earlier, ask 2 questions. Has its meaning become clear by now? If yes, move on without analysis. If the visual does not make sense yet, does it seem important? If yes, use the strategy to interpret the visual in a systematic way. The whole. Look at the entire visual. Look at the title and predict the graphic's purpose. This caption seems to be an explanation. Successive pictures taken at equal time intervals of a car in 4 different kinds of motion. The car is accelerating in C and D, but not in A and B as shown. From the caption, predict the purpose of the graphic, such as, I predict the purpose is to exemplify acceleration. Now, look at the whole visual and break it into its parts. How is this graphic structured to communicate information? Look at the 4 rows, each labeled with a letter. Notice that each row has 4 cars. Look at the 2 words at the top of each row, velocity and acceleration, with an arrow or a 0 by each. Notice that the arrows are either gold or blue. Next, select one part of the visual and zero in on it to see what it communicates. Start with the top row, row A. Notice that all the cars are equally spaced. Velocity has a yellow arrow and acceleration has an equal sign and a 0 behind it. Be sure you know the meaning of the key words, velocity and acceleration. Scan the text near the graphic for definitions and read those definitions. Return to the top row of the visual. Realize there are not 4 cars, but rather 1 car at 4 different places across time and space. Because the cars are evenly spaced and acceleration is 0, you can now state what this row is showing. A car is moving along a road maintaining a constant speed. No change in its speed means there is no acceleration. Now complete the same process for other parts. Focus on one part to learn from it. For B, the drive is steeper and the cars are still equally spaced. This means the speed stays the same, so again, no acceleration. Ask questions throughout the process. For example, if the velocity stays the same with no acceleration and the car is going uphill, doesn't it use more energy to maintain that same speed? For C, 2 things in this visual indicate increasing velocity: the blue arrow and the extra space between the last 2 cars. This means the car is accelerating. For the bottom row, D, see that the car is slowing down. Your evidence? The direction of the blue arrow and the closer proximity of the last 2 cars. This change indicates acceleration, but in this case, the type of acceleration is called deceleration. Now that you know about each part in isolation, compare and contrast one part to another to see how the two relate to or are influenced by each other. Let's contrast the first row to the second row. Both rows have consistent velocity, so there is no acceleration, but the second row shows the car going uphill. What point is the author trying to make? You might predict that more force is required for the car going uphill because of gravity. But since there is no change in speed, there is no change in acceleration. Now contrast the first row to the third row. Both rows show the car moving on a level surface. However, the third row has the blue arrow, and the space between each pair of cars is becoming farther and farther apart. You realize this indicates a difference in speed between the cars in row A and the cars in row C. The car in row C is accelerating, while the car in row A is not. You could continue contrasting and comparing one part to another as long as new insights keep coming. Now look at a single part and relate it to the whole graphic. Explain what the single part contributes to the graphic. Look at row D and try to understand its influence on what the whole graphic is trying to communicate. These 2 questions help. What does this part contribute to the whole, and what understanding would be missing without this part? Your conclusion may be that row D shows that velocity slowing down is a type of acceleration. This seems to contribute 2 important concepts. It again validates that acceleration is a change in velocity, but it also adds that this change can be a decrease as well as an increase in speed. Continue relating individual parts to the whole until doing so no longer adds to your understanding. Look at the whole graphic again. Does it make sense now? In your own words, create your interpretation of the graphic by pulling everything together to synthesize what they mean. Write this takeaway message next to the graphic. If any part of the graphic does not make sense to you, either work on the trouble spots using the surrounding text to help you, or make note of your questions to keep in mind as you continue to read. Continue reading, and whenever you come to a marked visual, repeat the same steps. You may find that taking the time to understand one difficult visual makes the remaining visuals faster and easier to interpret. After you finish reading the chapter, reread your purposes so they are fresh in your mind. As you review the chapter, explain how each graphic you come to relates to the whole thing. Depending on your major, this might be a must-do strategy. Imagine learning mathematics without equations, art history without the artwork, or physiology without diagrams showing the processes. This strategy, visual and technical reading, may seem laborious at first, but after you learn it, it becomes faster, easier, and more natural. It is a powerful and systematic way to analyze and learn from the hardest graphics in your text.